Welcome back. Today we'll explore the product rule of exponents. When I see the word product, I immediately think multiplication. Today, let's see what we can learn about multiplying with exponents.
Cool. So example problem number 1 tells us that 2 to the power 2 times 2 to the power 4 is equal to blank. Let's parse this out. We know from the previous lesson that 2 to the power 2 is the same thing as 2 times 2. Also, 2 to the power 4 is equal to 2 times 2 times 2 times 2. Now,
I wrote the parentheses in green to show which ones are which, but I actually don't need them because we're multiplying the whole way through. That's why I'm writing 2 times 2 times 2 times 2 times 2 times 2 in red this time, without parentheses to show that they're all the same thing. Now what I notice here is that 2 appears 6 times. So I'm going to write in blue 6 times to show that this 2 is multiplied by itself 6 times, and write 2 to the power 6, which is 64. Now I found this answer, but just to make sure, I'm going to double check. So I'm going to write check here, and I'm going to find 2 to the power 2, which is equal to 4, 2 to the power 4, which is equal to 16, and then I multiply them together. 2 to the power 2 times 2 to the power 4 is equal to 4 times 16, which is also equal to 64. So write down 2 to the power of 6, which is equal to 64, but I'm also noticing here that the base of 2 is the same, and 2 plus 4 is 6. Now I don't know for sure, so I'm going to move on to another problem to see what I'm thinking. Now let's look at another example problem to see the relationship between the exponents and the product. Now, we have parentheses minus 3 to the power of 2 times parentheses minus 3 to the power of 1. What is that equal to? Well, I know here that minus 3 to the power of 2 is minus 3 times minus 3. I'm including the parentheses here because it's a negative number and that's really important. I'm also going to put it in orange to show you exactly which one is which. Finally, I'm going to put that parentheses minus 3 to the power of 1 in light green to show that it's by itself. Lastly, to further show you that they're different, I'm just going to put parentheses around the orange part and the green part to show that these are two different numbers that we're multiplying together.
but as we just went over, that's not necessary. We're doing multiplication again. As long as we're making sure that we're being careful about our parentheses, we can combine it together without those extra parentheses there. I'm going to put it in blue to write minus 3 times minus 3 times minus 3. I notice that that's 3 times, so that's equal to minus 3 parentheses to the power of 3, which is equal to negative 27. Now, I want to double check. So I notice that minus 3 parentheses to the power of 2 is equal to 9, minus 3 to the power of 1, which is equal to minus 3. So therefore, that minus 3 to the power of 2 times minus 3 to the power of 1 is equal to 9 times minus 3, which is equal to minus 27. I noticed I forgot a negative sign there as well. So I'm going to write that parentheses negative 3 to the power of 2 times parentheses negative 3 to the power of 1 is equal to parentheses negative 3 to the power of 3, which is equal to negative 27.
Now I'm noticing here that the same thing that happened earlier is happening again. If you look at the minus 3 and the minus 3, the base stays the same, but this result is minus 3 parentheses to the power of 3. But if we look at the exponents, that's a 2 and a 1, and it seems like it's no accident that 2 plus 1 is 3. Earlier we saw an example where 4 plus 2 is equal to 6, and so we can add the exponents together when the base is the same. It turns out that that's happening here as well. It actually turns out that this happens every single time. We have something called the product rule of exponents, where as long as the base is the same, we can simply add the exponents. X, m, and n are here are numbers, which means that the base and the two exponents are numbers. And if the conditions are met, as long as the bases are the same, all we have to do is add the numbers to get the final answer. That's an amazing shortcut, and that's going to help us a lot.
Let's look at example problem number 3. We're going to do 1 to the power of 2 times 2 to the power of 3 times 1 to the power of 3 times 2 to the power of 2. Now, let's see how the product rule that we just learned applies. This is equal to 1 to the power 2 times 1 to the power 3 times 2 to the power 3 times 2 to the power 2. Notice how I'm just rearranging all the numbers here because it's multiplication. When you're only doing multiplication, you can rearrange it however you want. And after we do this, and after we put it in blue and in orange, it's pretty easy to see where we can combine things. I'm noticing that 2 and 3 can combine to get 1 to the power 2 plus 3, and 3 and 2 can combine to get 2 to the power 3 plus 2. As you see from the first row to the second row, you can do 1 to the power 5 times 2 to the power 5 because we're just adding up the exponents that belong to the bases of 1 and 2. We find 1 to the power 5, which is 1, and 2 to the power 5, which is 32, to get a total of 32. And I'm going to write this now in that box up there too.
Now, just to make sure, we're just going to check one more time. I'm going to go through each and every one of them to find that 1 to the power 2 is equal to 1, 2 to the power 3 is equal to 8, 1 to the power 3 is equal to 1, and 2 to the power 2 is equal to 4. I'm going to multiply them all together to get 1 times 8 times 1 times 4, which is equal to about 32.
Cool. We have one last example problem left. You've worked hard until now. You've got this. We're almost done. So this is another kind of example problem that you might see. When you first look at this, you might think, oh, 3 to the power 2 times 9. There's nothing for me to do here. Because as we noticed before, that rule that we figured out only really works when the bases are the same. Once again, that rule only really works when the bases are the same. And the bases are the big number that's on the bottom. But actually, there's something hidden in this piece right here. This whole thing is equal to 3 to the power 2 times 3 to the power 2. Why? That's because of the fact that this 9 right here is actually 3 to the power 2 in disguise. 3 times 3 is equal to 9, so this is a disguised 3 to the power 2. So once we write it like this, it gets a lot easier. We can rewrite this as 3 to the power 2 plus 2, which is equal to 3 to the power 4, which is equal to 81. Now, I know you're getting tired of me saying this, but I'm going to say this one more time. You need to check your work. So I'm going to check it right now, and I'm going to put it in light green this time. 3 to the power 2 is equal to 9. So 3 to the power 2 times 9 is equal to 9 times 9, which is equal to 81. And I'm going to write this in the box up there. We just checked their work, and now we can see that when you have bases that are the same, you can just add the exponent and make it really simple for you to solve these problems. Now, let's go over the vocabulary really quickly. We just went over this yesterday, but I want to go over it again because of the fact that this is really important. It's really important that you're using the terminology correctly, so that's why we're going to go over it again today. X to the power of n, right here, where n is the exponent of x and x is the base of n. Finally, you learned something new today. You learned that when you multiply two numbers x, y together, you are finding their product, x times y. That's something that's really important that we are using. You've seen the word product before in elementary school. We're using it again because we're doing the product rule of exponents, which means that we are doing a rule that happens when you multiply exponents together. So let's quickly review and then I'll let you go. If you're multiplying, I'm going to try that again. If you are multiplying two numbers with the same base, then you can add their exponents. For example, if you have minus 2 parentheses to the power of 3 times minus 2 parentheses to the power of 5, that's the same thing as you writing minus 2 to the power of 3 plus 5. And that's the same thing as minus 2 to the power of 8, which is about 256. Sometimes numbers with the same base are hidden. We learned that with example 4. For example, if you have 4 times 2 to the power of 4, what do you think might be hidden here? Well, I see the 4 right here, and I immediately think, oh, that's 2 to the power of 2. Once you do this more often, you will see these patterns more and more often. I can do that times 2 to the power of 4. That's this one right here. And when I multiply them together, I get because I'm adding them together, 2 to the power of 2 plus 4, which is equal to 2 to the power of 6, which is about 64. Great job today. You worked really hard. We've mastered something that was very, very difficult. Good luck on the homework. You got this.